Okay, section 2.4, arc length and surface area. This is going to be a short and easy section, so I'm sure you are happy to hear that. The arc length formula is in this box. Sometimes we write it with a y prime instead of f prime of x squared. We'll just write y prime squared. It's a little shorter. Either one is fine. The steps are, well, one, the integrand is a little bit long to find the square root of 1 plus f prime of x squared. So sometimes it's easier to do it in steps. So I just broke it down into two steps. One, find y prime and simplify that expression that you have to integrate, then integrate it. So let's look at an example. Find the length of y equals 2x to the 3 halves on the interval from x equals 1 to 2. Okay, we're going to need y prime. So we'll bring a 3 halves down. That cancels with the 2, and that gives us 3x to the subtract 1 from the exponent. New exponent is 1 half. Y prime squared is, you have to square all of this. That's 9x. All right, so in this case, our integrand, the square root of 1 plus y prime squared, is going to be the square root of 1 plus 9x. And there's nothing to simplify. We're going to have to integrate that. The arc length will be the integral from, here are the limits, 1 to 2. We want the square root of 1 plus 9x, which I'm going to write as 9x plus 1 to the 1 half, and I'm going to do a u sub. So u is 9x plus 1, du is 9 dx. I don't have a 9 dx, I just have dx, so 1/9 du is dx. So this is 1/9 the integral of u to the 1 half du. And let's change those limits. Instead of 1 and 2, we'll put 1 in for x. Here's u. When I put 1 in for x, I get 10. And when I put 2 in for x, I get 19. So there's my new integral. And I integrate to get 2/3. So I'll have 1/9. I'll do scrap paper over here. 1/9 times 2/3 is 2/27. U to the 3 halves between 10 and 19, which is, really we're not going to be able to simplify it at all. It's 2/27, and then 19 to the 3 halves minus 10 to the 3 halves. And that's as good as we're going to get it. You're going to do practice number 1 for when you turn in your lecture notes. So I have the answer at the end. So you might want to pause before I move on and make sure that you can do that one. I've got 2 hints for you. I mean, you can always look at the solution if you get stuck, but my 2 hints are: 1, you're going to need a common denominator for y prime squared plus 1. You'll have to write that with a common denominator. And my second hint is if you have to integrate something like, well, if you just have to simplify the square root of 1 over, I don't know, 25, any fraction, okay? By rules of square roots, by rules of exponents, that's the same as the square root of the top over the square root of the bottom, okay? But the square root of 1 is 1, so we'll get 1/5. So after you get a common denominator, when you integrate, you'll have a big old square root, dx. You'll integrate from -1/2 to 1 half. I'm not going to give away what should be underneath that square root, but it'll be a fraction. And you might say, well, I have no idea how to integrate that. My hint is to take the square root of the top and the square root of the bottom separately, and you'll see that the top will be 1. I'll give you that much. Square root of 1 is 1, and so then you'll recognize how to do it from there, I believe. Okay, so let's move on to the second part, which is surface area for surface of revolution. And so there are 2 formulas. You don't have to memorize either one. If you want you to do it on a test, I'll give you the formula. We just don't use it often enough to have to memorize it. We're going to, in this example here, we're going to go about the x-axis. So we're going to use this top formula. It's a lot like the arc length formula, except out front, there's a 2 pi and an f of x. Otherwise, it's the same formula. Okay, so we're going to need square root of 1 plus f prime of x squared. So first let's start with our f prime of x. Our f prime of x is the same as y prime, which is, think of y as 3x to the 1/2. So the derivative is 3/2 x to the negative 1/2, which is 3 over twice root x. That's a 3. So 1 plus y prime quantity squared is going to be 1 plus 3 over twice the square root of x squared, which is 1 plus, you have to square the top and square the bottom, 9 over 4x. And so now let's put together our integrand. I think we can start. S is equal to the integral from 3 to 4 of 2 pi f of x. F of x is 3 root x, and then square root of 1 plus 9 over 4x dx. All right, rule of square roots. Square root of a times the square root of b is the square root of ab. So I'm going to combine this as one square root. And I'm going to take that 2 pi, which is sort of annoying me, and bring it out front. 3 to 4. Oh, you know what? I'm going to take that 3 and combine it with the 2 and bring out a 6 pi. So we'll have 6 pi out front. And then combine these two square roots. So x times 1 is x. And then x times 9 over 4x is 9 over 4. So there's my new integral. And I'll do a u sub. I'm going to let u equal x plus 9 over 4. du is dx. Perfect. So this will become 6 pi integral. We'll change our limits in a minute, of u to the 1/2 du. And let's put on our new limits. When x is 3, so when x is 3, u is 21 over 4. So my lower limit is 21 over 4. And then when I put in 4, I get 4 plus 9 over 4, which is 16 plus 9, so that's 25 over 4. That's my new upper limit. So that's my scrap paper over there. So now I'm ready to integrate. So we're going to have 4 pi u to the 3/2 between 25 over 4 and 21 over 4. And so this is going to be, I'm going to have to take out my scrap paper here. 4 pi, I'm going to get 25 over 4 to the 3/2 minus 21 over 4 to the 3/2. All right, so like I said, it's a pretty easy section, and that is the end of this section.